Welcome to the HiRSE Summer of AI for RSE. If you want to learn more on how AI is changing the way we write and work with research software, this collection of episodes is for you.
Hi and welcome to this video of the mini-series Summer of AI in Research Software Engineering, which will be about using AI for research data management software. Now, before we start the main video, first let's get on the same page. So the term AI was coined in 1956 and there have been many advances over time, such as, for example, in 1997, when the first AI was beating a human chess world champion. And all these advances eventually led to the state which we have today. Yeah. If you're more interested in the history, then pause the video and look through the graphic. Now, what do we mean when we talk about AI? AI involves techniques which allow machines to emulate human behavior, to learn, solve problems, and so on and so forth. So, in a traditional sense, even a light which turns on due to a motion sensor could be considered AI, which of course is not what most people mean by it nowadays. Now, a subset of AI is machine learning, where machines learn patterns and statistics based on some dataset. Deep learning is a subset of machine learning, which uses neural networks to learn these statistics. And generative AI is a subset of deep learning, which generates text, images, and other media based on inputs. And due to the transformer architecture, for example, we have models like GPT and Qwen, which are trained on huge amounts of data and have billions of parameters. So they are very much generalized and can solve many tasks without any previous fine tuning. Many tasks could also be solved by much smaller and more specialized models. But yeah, anyways, right now large language models are very much hyped. There also are risks and chances which come with it. I want to start with the risks. So there, as you all know, the developments go along with high energy consumption, high water consumption, risk of job replacement and misuse. Yeah, there will also be a separate talk on ethics in a separate video. Now, there are also chances such as easier access to knowledge, and there are studies which show that some productivity gains and faster research is possible. And also very promising is that personalized research, medicine might become much cheaper using AI systems. All right, so now let's get to the main part of this video. I'm a PhD student at University of Stuttgart and focus on research data management. And research data is often stored in some arbitrary ad hoc data structures and understandable only by the person who directly works with the data. Now, one goal that we have is to make data more findable, accessible, interoperable, reproducible, machine readable. Because the idea is if we can make data well structured, then this makes it much easier to do further processing, analysis, to apply machine learning, and also for others to use the same data. One way to achieve this is by introducing schemas or data models, which describe essentially how the data looks like, what are the constraints, maybe semantics also. Now, if we have such a schema which describes our research data, then first of all, it's easier for people to deal with the data, to validate it, but also then large language models, for example, are very good at understanding data and, for example, at generating analysis code, at generating mapping code, and so on and so forth. So what my work is a web-based schema editor for JSON schemas, which also based on a schema generates a web interface to edit instance data. Also, we have a paper on AI assistance, which I'm going to demonstrate, that makes it much easier to work with such schemas by using some AI features. We also have some work on mapping research data to the semantic web, which I will also demonstrate in this same video. All right, so let's jump right ahead into the live demonstration. The live demonstration is inspired and based on research of Esengül with slightly modified values from chemistry. So let's jump right into it. All right, so this is our experimental data, which is a Excel sheet with 15 experiments in chemistry where we combine a metal salt with a ligand for a certain time under a certain temperature, and we get a new product which is either pure or not pure. And now we want to create a schema for it using different AI assistance tools, which I will now demonstrate. Okay, so first let us open metaconfigurator.org, which is the tool which we develop. And then let's click import data, import CSV data, and let's select our document. Okay, import. Now what we see is our experimental data, and it was already converted into a JSON document. We see the raw JSON document on the left side, and on the right side we see the same information in a graphical user interface. Now if we go to the schema tab on top, we can see that there also was a JSON schema automatically inferred based on our instance data. We can now make changes to it. For example, we see that the purity was inferred as a string, but it is a true or false value. So more suitable would be Boolean. Now, in the same way, if we go back to our data, we will notice, for example, for temperature and duration, they contain the value and unit together, but it would be more clean to model them separately. So let's open the AI prompts view. Let's close the text view. And let's ask or send a prompt. The temperature and duration both contain value and unit. Split both into two fields. Okay, now we have sent the request and our schema has been updated. Now we have a temperature value, temperature unit, duration value, duration unit. This happened based on a service in the background, a large language model. In this case, we are connected to the Helmholtz BlaBlaDo service from University of Jülich, which provides free large language model services to academics in Germany. I very much recommend you to check it out. But we can also connect any other large language model endpoint with our tool, which is compatible with the OpenAI API. All right. Now, if we go back to our data tab, we will see all kind of validation errors. For example, purity says it must be Boolean, but right now it's a string. So how do we fix this? We can use another large language model based service, which is transform data to match the schema. So let me press just one button, and it now generates a mapping rule to translate from the existing document to a new document which satisfies the schema. For example, for purity, it says take the existing value and set it to true if yes, otherwise false. For the temperature value, it takes the substring before the unit, and so on and so forth. Our philosophy is to not apply large language models directly on the data if not needed, but instead use them to generate mappings, to generate source code, to generate queries, because all of these can then be checked, they can be verified, they can be reproduced, they can be used again on new data, and there's no risk of hallucination or anything, as long as if you check the resulting mapping or whatever code you have. Okay, I pressed apply mapping, and now our data satisfies the modified schema. So what do we get by having a schema? For example, we can generate some markdown documentation. Okay, one use case. We can also generate source code in many different programming languages, which represents our data structure. We could also export our schema into another format, for example, to some, let's say XSD, if you would have some XML document, or Shackle. Although this is only a structural conversion, this is not a semantically proper conversion. Only the structural constraints are converted. But anyway, so there's all kind of things which we can do. We can also, as you have seen before, validate our document. And having such a schema is very useful now if you want to use large language models to deal with your data. Okay, let's go back to the data tab. What we can also do is we can bring our data to the semantic web. So let me open the RDF view, which gives us one warning that our data essentially is not yet in JSON LD, not yet in the JSON linked data format, but we can convert it. And here we also have essentially we can provide mapping instructions in human language, natural language, and then generate mapping code. Because this mapping task is a bit more complex, I will, just to be sure for this demonstration, use some other models. So let me use GPT-4o, also a bit older, but good enough. And let's change here to the OpenAI endpoint. And I also have to provide an API key, which is not needed for the BlaBlaDor endpoint, because we as like a meta configurator team provide a BlaBlaDor key essentially to everyone indirectly. So the AI assistance here can be used without any key, as long as you use the BlaBlaDor interface. Okay, now let us provide mapping instructions, how we want to map it into the semantic web. I have already prepared the instructions because they are quite detailed. Essentially, you need to know very well which ontologies to use, which terms to use. All of this needs domain and expert knowledge, otherwise the mappings will not really make sense. And yeah, I have provided all of these, and click one button to again generate mapping, a mapping configuration in the RDF mapping language, RML. Yeah, and for example, we want to use QUDT for units. Okay, it seems like some mapping was generated. Let us apply our mapping, and now we have triples and the knowledge graph. Let's visualize our knowledge graph. And we see for each experiment, we have a small graph which connects the experiment and the corresponding properties. Now, another AI feature which we could use is to generate a query. We can query our graph, right? So let us, for example, query. I also have prepared one example query to list all the metal salt and amount for all experiments where the product is pure. Okay, so let us click one button and we have generated now a query which returns the metal salt mass and unit and value for each experiment where the purity is true. So let us run the query and we now have a table with our metal salt unit and amount. Yeah. Now, of course, regarding all these large language model based queries and mappings, depending on how well you write your hints on which model you use, the results can be better or sometimes also not good. Yeah. All right. So these are some examples of how large language models can be used or AI can be used in research software engineering, in this case for research data management. And yeah, in the same way, of course, you can also use it in your own research software to make maybe some parts more accessible for users, to allow them to navigate or manipulate things using natural language instead of writing code. Yeah. I hope you liked the video and see you on next videos.
Thank you for watching this episode. Please check out the slides on Zenodo linked below and see you next time.